Hello. Today we're going to talk about topic 3, section 6, Voronoi diagrams. Not sure if I'm pronouncing that correctly, but nonetheless, they're pretty useful actually. They are used to do school zones, which hospital to send you to, which pizza place you should deliver from, all these things, all about location. And if we draw one of these diagrams, it can help us divvy it up. So what I mean by that is imagine that this is Rickards, this is Leon, and this is Lincoln. All right, so how do we determine who goes where? You know, clearly if you live here, you should probably go to Leon, right? And if I live here, then yeah, I'm probably going to go to Lincoln. And if I live here, well, then that makes sense. But what if I live here? Where do I go? How do I determine which is the best side? I mean, they're not going to sit here and go the distance formula for every single one. We should find sections. So that's what we're doing. We're making cells. We're separating it into little categories. Okay, so for instance, here's a hospital diagram. You have your 3 pieces. Okay, so if I were to draw a line from hospital B to hospital A, and then make the perpendicular bisector, that's where I would get this line from. All right, then if I do the line from A to C, and then I can do a line from, let's see, B to C, and here. Once you draw all these perpendicular lines, they meet up here, and now you've got your sections. So everybody in this section is going to go to hospital B. Everybody in this section is going to go to hospital A. Everybody in this section is going to go to hospital C. All right, because that's the closest hospital to each of those homes. Any home in this area, the fastest hospital or fastest direction or whatever is this hospital. Okay, hopefully that's making sense. All right, so let's do a partially drawn diagram. We've got our 3 points in there, and we've already found point D from this perpendicular bisector of AB, and then this perpendicular bisector of AC. So now we need to find the equation of the third edge. So we want to find this perpendicular line. So it's going to help to know the midpoint of BC. So let's find the midpoint of BC. So that's going to be 4 plus 7 over 2. And 4 plus 1 over 2. So that's going to get us 11 over 2 and 5 over 2. All right, so now we also, well here, let me draw this. So if we get our midpoint, well that's not where it should, oh that is, sorry, these are done by halves. Okay, so that is our midpoint. We know it's also, that line is going to go through point D. So what we can do is we can use the slope from D to the midpoint. Okay, so dm. All right, so point D is right here. So the slope is, well, 1.5 minus, that one would be 2.5. over 4.5 minus 5.5. So we get -1 over -1, so 1. Slope is 1, it's going through that point. So the equation would be y minus 5 over 2 equals 1, x minus 11 over 2. Multiply everything by 2. Well, I guess I don't have to if I'm putting it in slope-intercept form. Sure. We'll start with that one. So we get x minus, we add the 5 over 2 to the other side. So we get negative 6 over 2, so negative 3. Or we can write it as, let's see, standard form would be x minus y minus 3 equals 0. Okay, so slope-intercept, standard form, depending on what I would ask for. Okay, I'll make sure I'm specific on the test. Okay, so what do I do if I'm going to add another point? Okay, so what if I have 3 hospitals, but a 4th location is added? So what do I do when I add a location? Well, simple. You just do all the perpendicular bisectors. First, you've got your new point here. You draw a line from A to D. Actually, I don't know why I'm not using this tool. So we draw a line from here, from the new point to all the old points, and then draw the perpendicular bisectors. That's what these are. So this is perpendicular bisector of this one. Okay, and then now you overlap the perpendicular bisectors with the old drawing, right, the original, and find the points of intersection. And that's where you can start to add this new addition right here, this line. I just noticed something strange. Alright, I just noticed this triangle there. That's not supposed to be there. This line. Wait, hold on. Let me fix this. Sorry, had to fix that real quick. Alright, so here you have your perpendicular bisectors, and then you can define your new lines. Okay, so still in between A, B, we're going to use that perpendicular bisector there, but then when we get between A and D, we're using that one. Between D and C, using that one. So see, we're just finding all those intersection points, and we're just cutting them off, right? See how between D and C, we know this is the midpoint, so this line needs to go away, right? Because there's no shape there. Or, I'm sorry, there's no, quote-unquote, hospital, whatever, pinpoint there. Okay, so for this one, all right, take a second, pause it, read it, you know. All right, what I would do is I would draw your lines. So, for instance, we added the new point A, and we want the new cell, so we need to make new perpendicular bisectors. Probably should have picked a different color. I'll fix that. Give me a second. Alright, so now we're going to draw our perpendicular bisectors. So for instance, AC, we know this is the midpoint, and since this has a slope of up 1 over 2, we're now going to go up 2 over 1 the other direction. Okay, so I'm just going to draw my little dashed line, or dotted, whatever you want to call it. Okay, and then I'm going to do this one. Okay, so the midpoint is right here. Again, I probably should have picked a different color. Okay, so that slope was up 1 over 3.5. So now go up 3.5 and over 1 the other direction. 3.5 over 1 in the other direction. Okay. And yeah, it's getting confusing. Alright, so let me draw those lines. And get rid of the perpendicular bisectors. So get rid of that one. Get rid of that one. And then now we need this red one. So we already have the midpoint, which is kind of funny. It went through that green one. Oh, I need a different color. Okay, so we'll use purple. And so that slope was down 1, right 3. So we're going to go up 3 over 1, up 3 over 1. So now we have this one, so we can get rid of this line, and we can draw this perpendicular bisector. Okay, so now what do we need to get rid of? Okay, so we know this is the halfway point, so we don't have anything here, so I think this is useless. And this part's useless. And B, let's see, this is a halfway mark. Oh, yeah, our new spot. Okay, since this red is the in-between of A and B, we can eliminate it like this. There we go. So this is our new Voronoi diagram. Really don't know if I'm saying that right. Okay, so now, all right, so that's copy the diagram, add one more site, A, and this is the new cell, so all these lines. Okay, now let's see, the last thing, the closest site to K, which is 4, comma, negative 1.5. Well, negative 1.5 is right here. That's where K is. So that would be the closest to B. So point B would be your answer here. Okay, because it's in that cell. Okay, so for this one, you want to find the line equation that represents the edge of the region between A and B. So if we're using A, which is 2, 5, and B, which is 4, 1, then we should find several things, right? The midpoint, and then the slope. So the midpoint, 2 plus 4 over 2, 5 plus 1 over 2. So we get 3, 3. Then the slope is going to be 5 minus 1 over 2 minus 4. So 4 over negative 2, so negative 2. So the new slope is positive 1/2. So our equation is y minus 3, 1/2, x minus 3. So in slope-intercept form, that would be y equals 1/2 x. Let's see, that's minus 3/2, and then we added the 3 over to the other side. So that's what? 6 over 2, so plus 3 over 2. If we want to put it in standard form, we could also write x minus 2y equals, nope, gotta leave that over there, so plus 3. All right, let's see how they wrote it. Okay, so they put it in standard form, typical. Okay, I want to make sure that you know them all, though. Okay, hopefully that makes sense. Again, we just found the perpendicular bisector, okay? But that's what that Voronoi diagram is. Okay, so don't forget, these formulas are going to be on the IB exam, so you will have them in case you freak out, okay, or start to second guess yourself. All right. Also, I just kind of thought this was kind of cool just because, we're in the middle of a pandemic. But you can use these diagrams to find the source of an epidemic, right? Finding where those, where points of contact was made. So just kind of like a neat little subtopic. So if anybody wants to continue that research, that's very interesting. So let me know what you find. This little side thing. Okay, so let's apply it, right? One of those application problems. So the first thing you want to do is draw the cell for site D. So hopefully you can trace this and then see if you can draw another one. So you want to pause it, and I'll pop up the new one. All right, so hopefully you could draw this and you found your new perpendicular bisectors, and this is your new figure. Okay. Now you want to write the equation. So part B, well, you want to use A and D. So A is 1, 3, and D is 2, 1. So go ahead and find your midpoint and find your slope. Take a second, do that. Pause it. Okay, hopefully you got this for your midpoint and this for your slope. The new one, it should be 1/2. And then now you want to take a minute, pause it, find your equation. Okay, so hopefully you got this for your equation. Standard form would be this one. Okay, so now if 1 unit represents 1 kilometer, find the site which has the largest deliver area. Okay, so area. Okay, so calculating the area is kind of gross, but honestly you guys could figure this out. Okay, here we have a square. All right, now you break it into sections. All right, here you've got a vertex and a vertex here. So you can find the points of intersection between those lines. And then here, if you draw a line going this way and a line going this way, well, now all we have is a bunch of smaller triangles and rectangles. How do you find the area of a triangle? 1/2 base times height, length times width. Okay, so you literally sit there and figure out the area of each one. So you find the intersection of all these points. Okay, let's see. I believe I drew this wrong. This should have been at sorry, the intersection was at closer to 3, not above 3. Yeah, it's not really drawn to scale. Okay, so we know this point is 3, 3, and this point is 3, 2.75. And so now it's just a matter of divvying it up. Okay, so area A would be, I'll use the highlighter so I don't, eliminate everything, would be all of this. So you'd want to find I know, I'm getting there. I gotta get it all, sorry. Okay, so find the area of that triangle. Let's see. So for instance, the area of this triangle, that height is 3, that distance is 3. So 3 times 3 is 9, divided by 2 is 4.5. Then you have this distance is 0.75, right? The difference in y's. That is 3. So 3 times 0.75. So what is that, 2.5? And this was, what did I say, 4.5? Yeah. And then this one, we have, what is that, 1.75 height here and 3. Okay, so 1.75 times 3 divided by 2, we get 2.625. Okay. That doesn't seem right. Hold on, I think I added something wrong. Okay, so on here, I don't know why I keep getting 7.3, but Cognity is getting 7.5. Whatever. Cognity is saying the answer or the area for this for area A. Oh, for site A is around 8. Site B is around 9. Site C is around 11. And site D is around 8. But then that's not... they rounded up. Okay, so they rounded. That's what it is. Okay, so then here, the largest delivery area should be C. Oh, nearest square kilometer. Okay, so point C. All right. Well, go figure. Well, I just thought it was ironic. C. Anyway, didn't mean to do that. Can you tell I'm tired? Okay, hopefully this makes sense. If not, just ask me in class. I'd be happy to work out this some more.